All right, let's get right into it. Today, we're going to dig into the real architecture of information, exploring some incredibly powerful and honestly elegant ways to structure data. We're talking about advanced entity relationship modeling patterns. Let's go. You ever look at a database schema and just kind of nod and think, wow, that's smart, while another one just feels, I don't know, clunky and confusing? It happens all the time. And it makes you wonder, right? Is there some kind of secret sauce to building those really clean, intuitive, and efficient designs? Well, here's the thing. It's not magic. Not at all. It's about knowing how to recognize common problems and then applying these established, proven solutions, what we call design patterns. Think of them like a toolkit for a master craftsman. They let you solve really complex data modeling challenges with some serious elegance and precision.
So in this explainer, we're going to build out that toolkit. We'll start with a quick refresher on strong relationships, just to get our bearings. Then we'll unlock the power of what are called ID-dependent entities. After that, we'll get into structuring supertypes and subtypes, navigate the tricky world of recursive relationships, and finally, learn how to do a little detective work by inferring models from existing forms.
Okay, first up, let's just do a quick refresher on the absolute basics, strong relationships. These are the fundamental building blocks of pretty much any data model you're ever going to build. You've got your one-to-one, your one-to-many, and of course, many-to-many relationships. These are the core concepts, the foundation that we're about to build everything else on. Okay, so let's build on that foundation. This is where things get really interesting. See, beyond those strong entities, there's this powerful type of weak entity called an ID-dependent entity. The key thing to know is that it literally cannot exist without its parent, and its identifier actually includes the parent's identifier. Now, that dependency might sound like a weakness, but it's not. It's a feature, and it solves a ton of really common modeling problems. So let's start with our first problem. We just mentioned that many-to-many relationship, right? Like employees can have many skills, and a skill can be had by many employees. How do you actually build that in a database? I mean, you can't just stuff a list of skills into the employee table or a list of employees in the skills table. That would be a total mess and violate all the rules. So what do you do? The answer is something called an intersection table. And it's a brilliant, really simple concept. You just create a new table that sits right in between the two strong entities. This new table is ID dependent on both of its parents. Its primary key is what we call a composite key. It's just formed by combining the primary keys of the two tables it's linking. So a table called employee skill would have a primary key made of both the employee number and the skill ID. Simple as that. Okay, great. That handles the link. But what happens when the relationship itself has its own data? Let's say a company gets quotes for a part from many suppliers, and a supplier quotes prices on many parts. What about the price? Where does that go? The price isn't really a property of the part, and it's not a property of the company. It belongs to the specific quotation between them. And this brings us to our next pattern, the association pattern. Basically, our intersection table just evolves. It becomes an entity in its own right. So the quotation table doesn't just link part and company anymore. It also holds attributes like price, which only makes sense in the context of that specific relationship. Here's another classic headache. A company has multiple phone numbers, or maybe a student has multiple emergency contacts. Now, the rookie mistake here is to add columns like phone 1, phone 2, phone 3 to the main table. This is super inflexible and a total pain to query. What if you need a fourth number? You have to go and redesign the whole table. There's got to be a better way. And of course there is. This is the multi-valued attribute pattern. You just treat the attribute as its own entity. You'd create a company phone table, for example. Each row would have a single phone number and, crucially, the ID of the company it belongs to. This company phone entity is ID dependent on company. Now you can have one phone number or 100 without ever changing your table structure. It's clean, it's scalable, and it's the right way to do it. Okay, let's tackle one more scenario. Think about a university course, like Intro to Database Design. That's the general concept, right? But every single semester, there are specific offerings. Section 1 on Mondays and Wednesdays, Section 2 on Tuesdays and Thursdays. How do you model that relationship between the general idea and its specific concrete instances? This is where the archetype/instance pattern comes in. It's perfect for this. You have one entity for the archetype, like course, and a second one for the instances, like section. The instance entity, section, is ID dependent on the archetype, course.
This clearly defines the relationship and makes sure that an instance can't just exist on its own without its parent concept.
So, as we've just seen, these ID-dependent entities are just incredibly versatile. They are the clean, correct solution for handling many-to-many relationships, storing data about those connections, managing multi-valued attributes, and modeling versions of a master entity. Super useful. Next up, let's explore a totally different kind of relationship. We're not talking about a has-a relationship anymore, like an employee has a skill. We're talking about an is-a relationship. This is the world of generalization and specialization, and we model it with things called supertypes and subtypes. Now, when you're working with subtypes, the first thing you have to understand is that there are two main flavors. With exclusive subtypes, an instance can only be one type. A student is either an undergraduate or a graduate, but never both at the same time. With inclusive subtypes, an instance can be many things at once. A student could be in the hiking club and the sailing club. Getting this distinction right from the start is absolutely vital. But why go to all this trouble in the first place? Well, this quote really gets to the heart of it. Imagine you just put all student attributes in one giant table. An undergraduate would have a column for their GMAT score, which would always be null. A graduate student would have a column for their SAT score, which would be null. These aren't just missing values. They are values that are fundamentally inappropriate for that type of entity. Subtypes let us create tables where every single attribute is relevant, which gets rid of those nasty, value-inappropriate nulls. All right, now for a pattern that can feel a little mind-bending at first, but it's actually super common. An entity that has a relationship with itself. You can think of it as an entity looking in the mirror. This is called a recursive relationship, and it's essential for modeling things like hierarchies and networks. And just like relationships between different entities, these recursive relationships can have different cardinalities. A one-to-one recursive relationship could model a train, where one boxcar is coupled to exactly one other boxcar. The classic one-to-many example is an org chart, right? One employee manages many other employees. And a many-to-many is perfect for something like a bill of materials, where one part is made up of many other parts, and can also be a component in many other assemblies. Okay, we've covered a whole bunch of patterns for building new models. But what happens when you're faced with an existing system and you need to figure out the data structure that's hiding underneath? Well, this is where you become a data detective, and your clues are often the business forms and reports that people use every single day. The process is actually surprisingly straightforward. First, you just identify the main nouns on a report. Those are your likely entities, things like college and department. Next, look for repeating groups of data. A list of departments under a single college heading? That's a huge clue that you've got a one-to-many relationship. Then you have to actually confirm the cardinality with the users, because the form won't tell you everything. And finally, you take all your clues and you sketch out the ER diagram. So we have covered a lot of ground, from intersection tables all the way to recursive relationships. I'll leave you with this question to chew on. When you think about the most complicated, tangled data modeling challenge you're facing right now, which one of these patterns, the association pattern, the multi-valued attribute pattern, supertypes, or maybe a recursive end-to-M, could be the key to simplifying it and making it more elegant? If this explainer helped you add some new tools to your data modeling toolkit, we'd appreciate it if you'd like, share, and subscribe for more deep dives into the structures that power our digital world. Thanks for watching.